Good morning, students. In our previous class, we have studied the preparation of Grignard reagent from alkyl halides. And we have also seen that the carbon-magnesium bond in Grignard reagent is highly polar in nature. Now, owing to this polar nature of the carbon-magnesium bond in Grignard reagent serves as a fantastic tool for transformation of various functional groups in synthetic organic chemistry. So today we will learn how to synthesize various functional groups or various organic compounds starting from Grignard reagent. So we will study the synthesis of alcohols and carboxylic acids starting from Grignard reagent. Now, since Grignard reagent is a very good source of carb anions, so Grignard reagent can act both as nucleophiles as well as bases. Now, this nucleophilic property of Grignard reagent can be used as a very good synthesis route. Let us see how. This is carbonyl carbon. Now this carbonyl carbon, when you are treating with RMGX, that means any carbonyl group, when you are treating with RMGX, then RMGX will yield R minus. This is a carb anion, and this carb anion we can take it as nucleophile. See, this compound, that is any carbonyl compound, it can be aldehyde, it can be ketones. Now this is delta positive, so this carbon will invite this R minus. This is a nucleophile. So R minus will attack this carbon and C double bond O is broken, this bond. Then what we will get? We will get C. This is O minus. This is R. This R is coming from Grignard reagent. Now, in the next step, if we treat this with water oblique H plus, we will get OH, and this is R. Now, what class of compound is this? This is alcohol. So, Grignard reagent can be used to synthesize alcohol. So, first we will discuss the synthesis of alcohols from Grignard reagent. Now, if I ask you, what type of reaction mechanism is this? This is an example of nucleophilic addition. Now, suppose if this carbonyl compound is formaldehyde, then what will be your product? Here I will write H and here it will be H. So this is R CH2 OH. So when we will use formaldehyde with Grignard reagent, we will always get primary alcohol. So the conversion of formaldehyde to a primary alcohol can be done with the help of Grignard reagent. Now, instead of formaldehyde, if I change this to acetaldehyde, that means any aldehyde other than formaldehyde, then this will become CH3. This will also be CH3. So, what type of alcohol is this? This is a secondary alcohol or 2-degree alcohol. So, Grignard reagent with any aldehyde other than formaldehyde will always yield a secondary alcohol. Suppose if I change this to a ketone. Let us start with our most familiar ketone, acetone. So CH3, C double bond O CH3. This will become CH3 and this H will be replaced by CH3. What is the degree of this alcohol? This is a 3-degree alcohol because the carbon connected to the alcoholic OH, this carbon is connected to 3 carbon, so 3-degree alcohol. So, Grignard reagent can be used for the synthesis of 1-degree alcohol, 2-degree alcohol and 3-degree alcohol. Now always remember that formaldehyde plus Grignard reagent will always give you 1-degree alcohol. Any aldehyde other than formaldehyde, it can be R-CHO, your R- can be methyl. If it is methyl, then it is acetaldehyde, it can be propanaldehyde. So this with Grignard reagent will give you 2-degree alcohol. And what about ketones? Ketones with Grignard reagent will give you 3-degree alcohol. Now how can we get carboxylic acid using Grignard reagent? Let us see. Grignard reagent plus carbon dioxide will give you carboxylic acid. Let us see how. This is carbon dioxide. Grignard reagent is a source of carbon ion and our carbon ion is R-. So this will attack here. This bond will be broken. So we will get this with H plus. So carboxylic, this is carboxylic acid. Do you know what is this compound? This compound is known as ethylene oxide or oxyren. Now, oxyren plus Grignard reagent followed by decomposition of acid. What will be the product? Now, this Grignard reagent will give us R-. Now this R- will attack this carbon, this bond will be broken and we will get, say this R will get connected to this CH2. This CH2 is connected to this CH2 and this is connected to O, so it will be O-. In the next step, what will happen? In the next step, H plus. So this will become R, CH2, CH2, OH. What is the degree of alcohol? This is 1-degree alcohol, primary alcohol. So we have just now learned that formaldehyde plus Grignard reagent gives us primary alcohol. Now this compound oxyren or ethylene oxide will also react with Grignard reagent to give us primary alcohol. This is the final. Now let us see how ester reacts with Grignard reagent. What class of compound is this? This is carboxylic acid. Now this one H of this carboxylic acid, which H? The H attached with OH, is replaced by an alkyl group. Presently it is ethyl group. So ester plus, let us take Grignard reagent. This R and R, they can be same or they can be different also. Now let us see the mechanism of this reaction. So R minus, the carb anion, will attack this carbon and this C double bond O will be broken. You will get R CO minus. Now this R that is coming from Grignard reagent, O CH2 CH3 in the next step. So we will get R C double bond O. This is R. So this is a ketone. The reaction will not stop at this stage. This ketone formed will further react with RMgX followed by decomposition of acid to give you what? Just now we have learned that ketones plus Grignard reagent give us 3-degree alcohol. So COH R R. So ester reacts with 2 molecules of Grignard reagent to give you ultimately which product? 3-degree alcohol. Now suppose if you are changing this R MgX as CH3MgX. So here your product will be this RC double bond O, these are all intact. This will become CH3. Now here it will be CH3 and your alcohol, that is 3-degree alcohol, is CH3. Now if your ester contains here CH3. So suppose if your ester is CH3, what is the name of this ester? What is the mother acid? The mother acid is acetic acid and the name of this ester is ethyl acetate. Now let us see how ethyl acetate reacts with methyl magnesium halide. So here I will put CH3. Again here it will be CH3 and here again CH3. So we have learned some synthetic uses of Grignard reagent. We have prepared alcohols from Grignard reagent, 1 degree, 2 degree, 3 degree. So RNGX plus formaldehyde or oxyren will give us 1 degree alcohol. Now this Grignard reagent plus aldehyde other than formaldehyde will give us 2 degree alcohol. And ketones plus Grignard reagent will give us 3 degree alcohol. But at the same time, ester with Grignard reagent will also give us 3 degree alcohol. But remember, ketones with 1 molecule of RMGX or Grignard reagent will give us 3 degree alcohol, whereas ester will require 2 molecules of RMGX to give us 3 degree alcohol. We have also learned the preparation of carboxylic acid from Grignard reagent. How we have prepared? This is carbon dioxide H+. So these are the few synthetic uses of Grignard reagent. In our next class, we will continue with elimination reactions. For that, you will kindly go through the elimination reactions that we have already discussed in class 11. Thank you very much. Have a nice day.